Today's daily LeetCode problem of the day is magic squares in grid number 840. For this problem, a 3x3 magic square is a 3x3 grid filled with distinct numbers from 1 to 9. So in a 3x3 grid, no two numbers can be the same. So each row and column and both diagonals have the same sum. So for it to be a magic grid, each number has to be distinct, and each row in our 3x3 grid, each column in our 3x3 grid, and each diagonal has to have the same sum. So in this case, we have 4 plus 3 plus 8 is 15, 9 plus 5 plus 1 is 15, 2 plus 7 plus 6 is 15, 4 plus 5 plus 6, 15, 2 plus 5 plus 8, 15, 9 plus 4 plus 2, so on and so forth. They all equal 15. So this is a 3x3 magic grid, magic square. If we look over and shift one 3x3 to the right, so if we look from 3, 5, 7 over to 4, 9, 2, this is not a magic square. Even though it's basically mirrored, it is not. If we look, 3 plus 1 plus 2 is 6, 7 plus 1 plus 4 is not 6. So we only have one magic square in our first example. This is further explained right here. We can also have grids with just one number in them, which is not optimal. So the topics for this problem are array, hash table, math, and matrix. To solve this problem, we are going to check for the unique properties of these magic squares. So if we look at this example, in example 1, each diagonal adds up to 15. And so if we look up here, each magic square can only contain numbers from 1 to 9. So each of these distinct boxes must be between 1 and 9. A grid may contain up to 15. So there may be up to the number 15 in any of these squares. However, we are only counting from 1 to 9. In this first example, we can see that each possible sum adds up to 15. This is not a coincidence. For a magic square, every case scenario, for it to be a valid magic square with individual numbers where each column, row, and diagonal add up to the same sum, it must add up to 15. Why is this? Because we can see that the total sum of the entire magic square will be equal to 45. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, that equals 45. So the total value that this square must add up to is 45. And because it is a 3x3 square, that means we have 3 rows. These 3 rows must add up to 45 because they will contain every number possible. They have the 1, 2, 3, 4, 5, 6, 7, 8, 9. So they must add up to 45. Thus, each row must add up to 15. So with this knowledge, we can identify that each magic square will only have a set number of arrangements. And based off of my calculations, there's only 8 total possible arrangements of these numbers. And we can see them all here in this first example. One example is 4, 5, 6, and then we have 2, 5, 8, 4, 3, 8, 9, 5, 1, 2, 7, 6, 4, 9, 2, 3, 5, 7, 8, 1, 6. So this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. That is our total number of arrangements possible to make each row equal to 15, thus making the square equal to 45. So with these 8 possible arrangements, we can then narrow down our solution and how we can solve it. For every single one of these possible arrangements, basically, except for these edges, 5 is the middle element. So for any possible magic square, we need 5 as our middle element. It's part of 1, 2, 3, 4 different arrangements as the middle element. Thus, we always need 5 as our middle element because it wouldn't work with any other number there. then we can also look and identify that our even numbers are in the corners, 2, 4, 6, 8. So based with this information, we most likely need all of our even numbers in the corners. Furthermore, we can see all of the odd numbers are not in the corners. 1, 3, 7, and 9 are not in the corners. So using these constraints, we have 8 possible different arrangements of the numbers. So we can, while observing all these possible arrangements, we can write an algorithm based off of the possibilities with these squares. So if we look for a pattern here, either way, while solving, we're going to need our evens in the corners and our odds on the edges and 5 in the middle. So we can look and say 2, 9, 4, 3, 8, 1, 6, 7. This is one possible order. Or 2, 7, 6, 1, 8, 3, 4, 9 is one possible order. And we can use that possible order to check all of our magic squares to see if they follow in this little box kind of pattern. So for our algorithm, we're going to first initialize our answer variable. We'll then have a helper function to identify our magic squares. We could then initialize a sequence of numbers, which would be our 2, 9, 4, 3, 8, 1, 6, 7, or the reverse of that, which would be 7, 6, 1, 8, 3, 4, 9, 2, to identify our pattern, our edge pattern, as well as a reversed edge pattern. We can then use a string to store all the elements from our grid. So let's say our grid is 4, 3, 8, 9, 5, 1, 2, 7, 6. And then we can check if our sequence is found within this grid, or our reverse sequence is found within this grid. And as long as the first element is even, because we're going to start at the corners, and the middle element is 5, because we know that 5 needs to be in the middle of our subarray, then it is a magic square. So then we can return true and add 1 to our answer. And ultimately, after going through our entire grid, we can return this answer. So let's go ahead and implement this. We're going to start with, so these are our 4 steps. We'll initialize our answer, define our function, then iterate through our grid for each row and column, and return our answer. Our helper function is going to use the possible sequences and reverse sequence to account for all possible magic squares. So we can start by initializing our answer, which is just going to be int answer is equal to 0. We can then define our helper function. So our helper function is going to return a Boolean, and this Boolean is going to either tell us to proceed with adding 1 to our answer or not. So we're going to have a private Boolean, and then this is going to be a helper func. We're going to pass it a 2D integer array grid. We're going to pass it int row, and we're going to pass it an int column. These are going to be our 3 variables. So this is going to be our official grid, the same as this grid. We're then going to pass it our row, which is going to be the first loop we're going to go through up here. So we're going to loop through the rows, and then we're going to loop through the columns so we can get all possible subarrays. So we're going to pass it our whatever row we're on. We're going to pass it whatever column we're on so we can address the magic square from that position. So now that we're done defining the helper function, we can move on to iterating through the index of the rows and the columns. So we're going to have a nested loop. So for int row is equal to 0, start at the very beginning. Row plus 2 needs to be less than our grid.length, and then we can do row plus plus. So why are we doing row plus 2 is less than grid plus length? This is because if we are, for example, on row 4, or the first row, where 4 is at. If we move down to row 9 to check for a 3x3 grid, we're going to go out of bounds. So we need to stay at least 2 above the end of our grid. Same thing for the columns. So we're going to do for int column is equal to 0, as long as column plus 2 is less than our grid of 0 dot length, column plus plus. So we use grid of 0 dot length so we could get how many columns are in each row. We'll then ask if our helper func is true, and we're passing it our grid, our row, and our column. We can add one to our answer. So answer plus plus. After that, outside of our loop, we're going to simply want to return answer. And that is that. So because we are programmers, we're going to hope that this helper function works on its own. I'm just kidding. So for our helper function, we've already identified that there's technically two possible sequences that are possible. That being 29438167 or 7618342 if it is reversed. So let's go ahead and define those two possible sequences. So we're going to have a string seek. That's going to be equal to 29438167. And then we are going to go through it twice. So our string is going to be the same thing twice, simply because if for whatever reason we start at 9 or we start at 8, 1, 6, 7, 2, 9, 4, 3, that will be also in the string, because we're going to use if whatever string that we build is contained within sequence, then we can return true. So we can go ahead and double this. And then we're going to have a string rev seek, or the reverse of the sequence, which is going to be 7, 6, 6, 1, 8, 3, 4, 9, 2. And again, we can double that. So now that we have our two possibilities put down into variables, we can then create a string builder, which is going to store the border of our 3x3 grid, which we can then see if it is contained in either sequence or reverse sequence. So we're going to have a string builder, and it's going to be our matrix. That's equal to a new string builder. So we're going to take all of our indices in our border and add them to this matrix. So we're going to first flatten the indices that are going to be on the edge of our grid in the order that we want to address them. So this means we are going to look starting at the top left and go 0, 1, 2, and then this would be 3, 4, 5, 6, 7, 8, and then the 7th element, 6th element, and then the 3rd element. So we're going to kind of go in this little circle pattern. So we're going to use our integer array order, and that's going to be equal to a new integer array, and that integer array is going to be the pattern that we want to go in through the border. So 0, 1, 2, 5, 8, 7, 6, 3. That is simply just the order that we are going to traverse our border. After we identify that, we can then have a for loop that's going to go through these border indices. So for int I in our order, we can have our integer num, this is going to be a temporary variable, equal to the grid of row plus I divided by 3, and our column plus I modulus 3. So this num So by doing row plus I divided by 3, let's say we're looking at our fifth element, so this 1. So row is going to be equal to, let's say we're starting up here, so 0, plus I, so 5, divided by 3. So 5 divided by 3 is going to result in a 1. So we're going to be in row 0 plus 1, and then column is going to plus, we're starting in column 0, I modulus 3. So it's going to return 2, so 0 plus 2. So 0, 1, 2. That's going to get us our fifth indice, so on and so forth for all these numbers. It's just a simple mathematical expression to get us to each of these indices without going outside of our matrix. We could then have our number appended to our matrix string. So matrix.append num. Remember, we are adding the order we collect these numbers into this matrix string to compare it to our sequence and our reverse sequence. So after we go through that for loop, we're going to have our full matrix string. So we could do string, and we could call it our border. It's going to be equal to our matrix.toString. And then we can compare it to our sequence and reverse sequence now and return whatever the answer is. So we can return grid of row of column modulus 2 is equal to 0, as we're going to start at a corner. So we want to make sure that whatever corner we are starting on is divisible by 2, because we said that the evens need to be in the corners. So grid of row of column, the modulus 2 is equal to 0, and our seek dot contains our border, or our, seek rev seek dot contains our border. So as long as either of those contain our border, and one last check, if our grid of row plus 1 and column plus 1 is equal to 5. So as long as our middle element is equal to 5. So we're going to check first the corner that we're starting on is divisible by 2. We will then check if the pattern we have identified in the border matches either our sequence or our reverse sequence. And then we're going to check the middle indice to make sure that it is a 5 and not some random number like a 10 or a duplicate of any of these numbers. So by returning that, it should return either true or false to our helper function. And so that should pass our test cases. And if we submit it, passes our solutions. We're going to do this problem in Python. It's pretty much the exact same thing. So we have our answers equal to 0 for each row in the range of the length of our grid minus 2 for the column in the range of the length of our grid of 0 minus 2 for, if self dot helper func is true based off of grid row column, we can answer plus equals 1 and then return answer. So let's go ahead and define this function. So define helper func. It's going to return self, it's going to return grid, it's going to return row, or it's going to take row and column. So both sequences, so we have our seek is equal to the string 2 9, 4, 3, 8, 1, 6, 7. Go ahead and double it. And our rev seek is equal to the reverse. So we have 7, 6, 1, 8, 3, 4, 9, 2. Go ahead and double it. And then we're going to have our border, which is equal to an empty list. And then we can define it. So our border indices is going to be equal to 0, 1, 2, 5, 8, 7, 6, and 3. And then we can do for I in our border indices. Our temporary num is going to be equal to the grid of row plus I divided by 3, or column plus I modulus 3. Then we could do border dot append the string version of num. After that, we can convert it to a official string. So we're going to have our matrix is equal to string joined with order. And then we're going to return the grid of row of column modulus 2 is equal to 0. And let's see, and our seek dot find our matrix is not equal to -1, which also means that it found our matrix in the sequence, or rev seek dot find matrix also does not return -1, and our grid of row plus 1 of column plus 1 is equal to 5, meaning that 5 is in the, middle indice. You can go ahead and put this in brackets, and if we run, passes our test cases, and if we submit it, and it passes our solutions. So thank you, and follow for more daily LeetCode solutions.